All
Right.
right. All right. So, hello, everyone. Thank you for joining us this hour evening for today's developing for FPGA drivers with PCIe, for SoCs and cloud using WinDriver. My name is Shlomi Ovadia. I am a senior account manager for WinDriver here at Jungo. I will be joining Uriah Bertal, our WinDriver R&D manager or our head of R&D, in today's webinar. I will be putting a link in the Q&A section for anyone who may want to schedule a meeting to hear more about any of the topics we will be discussing today. There will be a link for you to schedule a meeting with yours truly in order to discuss anything from questions regarding WinDriver, questions regarding support, anything along those lines. If you just want to say hi, I'm happy to have a chat. Or if you have any good video game recommendations, I'd love those as well. Always looking for new things to do. So I'll put that in there in just a few moments. I will also ping it back up again at the end of the webinar. Additionally, if anyone has any questions, please feel free to use that Q&A section, and we're going to circle back to any and all of those, to as many of those questions as we have time for at the end of the webinar. So while I'm doing that, I'm going to pass things over to Uriah to get the ball rolling. Please.
Right. So, hello everyone. I'm Uriah, WinDriver R&D manager, and so today we're going to be discussing about hardware design in general, but specifically on FPGAs. So, hardware design has basically three layers: the physical layer, the logic and design layer, and the driver layer. Um, so we're going to quickly go over these two layers, which are not part of WinDriver originally, but are also an important part of the hardware development process. And then we're going to, of course, touch mostly on this on the driver side, which is our product, because we are a driver development SDK. But we still are going to touch these areas as well because you'll see soon that once we change these two, we can get some interesting environments, and still our driver is going to work even when we change the environments. So what's on the agenda? First of all, we're going to give a quick overview of what's an FPGA, and then we're going to talk about a little about PCIe related IPs and what are IPs in general. Then we're going to talk a little bit about AMD XDMA design. That's the DMA IP from Xilinx. And then Shlomi is going to talk about what is WinDriver, what compatible DMA samples we offer for different DMA IPs from the leading vendors of FPGAs. And then Shlomi is going to show you a demo on the PCI plus host configuration using Windows. And then I'm going to show you two new demos of new features that we have. First feature is the SoC. We're going to run the exact same design that Shlomi ran on the PC on an SoC. And then we're going to run the exact same design also on a cloud instance of AWS, cloud FPGA. So all these will be using the exact same driver and the exact same product, which is WinDriver, which is our product. So let's dive right in. So what's an FPGA? An FPGA is a field programmable gate array. It's a semiconductor device that allows users to reconfigure its internal hardware circuitry via software after manufacturing. So that means that you have this chip, and this is actually the FPGA, and everything around it is it's called an evaluation kit. And it comes out of the factory like this, but this chip could be reprogrammed in many, many different ways, and that allows for great flexibility. Unlike fixed instruction CPUs or GPUs, FPGAs utilize a massive grid of programmable logic blocks and interconnects to execute tasks in parallel. And this parallel architecture enables high performance and low latency processing critical for applications such as 5G infrastructure, high frequency trading, AI acceleration, and so forth. And what's nice, and also image processing. And what's nice about this from not just from the performance viewpoint, but also from the versatility point is that they're very, very reliable. And the good thing is that you can update them all the time. Like you don't need to remanufacture them again. You can just take this and reprogram it over and over again. So this is very good for the defense industries or the aerospace industries, where instead of, I don't know, going, I don't know, to the back of a plane and replacing some card, all you need to do is just connect to it from remote access and just reprogram it from afar. And that gives great flexibility in changing or updating your hardware designs on the fly. So
They're
that's,
also very pretty.
yeah, that's true. And we're going to show a couple of these today. So start drooling, Shlomi. And and the nice thing about these is that they're besides being pretty, is that they're very, very useful for many, many of our customers, and really help a lot in prototyping as well. Because instead of like, if you have a bug in your design, then you don't need to throw the card away once you found a bug. You can just reprogram the card again, and you can save a lot of chips and a lot of materials in manufacturing the card all over again once you find a bug in it. So first of all, we're going to have a couple of polls in this webinar, and we're going to ask you a question, and we'd like you to answer. We're going to give you a minute to do that, so feel free to do it right now.
We should have provided elevator music for this portion. Should have thought of that.
All right, the results are stunning. All right, you have 10 more seconds to go.
Get your votes in now, folks.
Get your votes in now before it's too late.
See which team wins. Let's see if I owe Uriah $5.
So I got to say that the results are, after 85% of the participants were answered, the results are kind of actually reflecting the actual pie chart of FPGAs in the world. 42% chose AMD Xilinx, 25% Altera, and the rest, the other vendors. And it's good actually, because we're gonna mostly show the stuff from AMD today, and they're the majority really. But this, for example, is an Altera FPGA. It's an Agile X5. All right, so I'm going to end this poll now. And do you see my screen, Shlomi? Can I carry on?
Yep.
Okay.
Please.
Okay. So we've talked a little bit about the physical side of what are FPGAs, and now we're going to talk a little bit about logic. So you have this card. It's a physical card. And now, again, you need to program it, you need to change it, and that's like a whole profession, really, FPGA engineer. So I'm going to touch a little bit about that, and then we could get to the interesting stuff. So we need to make an architecture in order to program the device. It doesn't come just programmed out of nothing. You need to build some kind of hardware design. So how do you do that? Well, you usually, what you do is you take logic blocks, which are these squares, and you just connect them to each other and configure them with your vendor's IDE. In this image, we have Xilinx Versal by AMD, Xilinx Vivado is the IDE from AMD, and we also have Quartus from Altera. So basically, if you put this in the application, you click this and you get a window and you modify things and you connect things, and that's how basically you build a design. Let's talk a little bit about different kinds of logic blocks. So you have memory bars. Memory bars are the base address registers that map internal registers in memory into the host system's address space for communication, usually when we're talking about a PCIe configuration. DMA is short for direct memory access, which enables high-speed data transfers between the FPGA and the system memory without using the CPU. Clocks are used for synchronizing different blocks for timing. Interrupts is the mechanism that is used to signal that some processes have finished or some processes are in process of making something, and usually that's the way that devices connect with each other or connects with the host computer. And offsets are values that pinpoint exact locations for data or instructions within a specific allocated memory region. We're going to show offsets later on in this presentation, so I just wanted to clear this and make sure that we're on the same table, on the same page here regarding all these terms. What are IPs? So IPs are pre-verified reusable blocks of logic, such as PCIe controllers or DMA engines that act as black boxes that you can just drag into your device, into your design, and they handle complex standard functions without having to write the underlying code and logic from scratch. Because basically, you can just write this code if you want, like write a code that does everything in code, but that's much harder than just dragging boxes into your design and connecting them. So this is an example from Lattice's Radiant. This is the IDE from Lattice. That all these companies, by the way, that we mentioned are our partners. Lattice, AMD Xilinx. We just finished a talk with Altera a couple of minutes ago. So all of these are WinDriver's partners, and we work together with them. So in Lattice, you can just, if you want to have like a DDR3 SDRAM controller, you can just drag this into your design, and it just, you need to connect it and configure it, and you don't need to write too much code. And that's really nice. But the problem is that even though it's really nice and it saves you time in not having to write the code, it's still not that easy to configure it and to make sure that it works with your driver. And I'm going to show a little example here. So this is the XDMA design by Xilinx. And the XDMA design is this part, actually. And these are other stuff that are connected to it. So if you click this in Vivado, you're going to get this window to configure that block. And you have 5 different tabs, and in each tab you have like lots and lots and lots of checkboxes and things to change and so forth. Which number of DMA channels and which kind of interrupts or polling are you using and which bars are going to be used, and lots of things to configure. And the problem is that customers that want to use WinDriver, for example, and Shlomi is going to show you in a couple of minutes what WinDriver is, but customers, first of all, they play around with their design and play around with these DMA blocks, and then they get to the driver, and then they have a problem because they configured it in a way that the driver is not aware of. And this is actually why we have a new section on our website called the example projects section, which I'm going to show in just a moment. It's a part of our customer portal, which is also a new thing in our website. So if you go to www.windriver.django.com, and the link is also going to be available in the chat even now. Shlomi can type it on the chat if he wants.
Oh,
I know you're so busy, and I'm disturbing you.
this was not in the script, Uriah.
Yeah, exactly. So in this portal, once you enter this portal, you'll have access to these example projects. And what's good about these example projects is that they have everything configured for you. For example, this XDMA, we give samples, like driver samples for a design for DMA, different DMA IPs like XDMA. So, but the problem is that XDMA has so many ways to configure it, like so many options, because I just showed them to you. But with our design, you can make sure that if you download the design from our page, you're sure to have a design that just works out of the box. And I'm just going to quickly show that. I'm not going to show it running out of the box, but I'm going to show the website. And here it is. So on our website, this is the FPGA example designs page, and you see that we have lots and lots of projects here available for you for all different kinds of kits, mostly from Altera and from Xilinx. So if you know the part number and you know which kit you're using and you know which IP you're using, then you can be sure that this sample, for example, is going to work out of the box. No need to touch any code, and that's amazing. Just need to download this from here, compile it with Quartus or Vivado, depending on the vendor, and run this sample from WinDriver, which is going to be covered by Shlomi in a couple of moments. And you're good to go. You have a running DMA sample code, which you can just edit and work with and start your project. And I think if you start from here, from something that is already running, you're in a very, very good place to start designing your logic in your hardware design. So I'm going to get back to the presentation now and carry on. Okay. So I'm going to hand the floor now. So we covered the physical part, we covered the logic design, and now we're going to get to the sweet part, the driver part. And for this, I present to you Mr. Shlomi Ovadia.
Thank you very much, Uriah. So, in order to understand WinDriver's part in everything that Uriah just described, or rather how everything Uriah just described builds towards WinDriver, we first really need to understand at a very basic level what WinDriver is. So WinDriver at its core is a driver development toolkit for USB, PCI, and PCIe. Today, obviously, we're focusing mainly on the PCI and PCIe aspects of it. It is cross-platform compatible between Windows, Windows ARM, Linux ARM, macOS, and we've recently added support for Zephyr RTOS as well. And we're always looking and adding new support and new features. So some of the things that are important to understand about the advantages of using WinDriver as opposed to trying to do things from scratch. There are several advantages. We have some of them listed here, but there are also many others. Some of the big ones are the availability of hardware. So as far as WinDriver is concerned, the way we like to describe it is WinDriver is silicone agnostic. It does not care where you get your hardware from, and we don't judge you for it. But whether you're using Altera, whether you're using Xilinx, Microsemi, Lattice, or any other vendor on the planet, or even if you're building something from scratch, as long as it identifies as a PCI or PCIe device, WinDriver will be compatible with it. So that is first and foremost one of the major hurdles that you avoid by using WinDriver. Furthermore, customizability. So WinDriver is infinitely customizable with its very easy to use, easy to understand, and as I mentioned before, cross-platform compatible APIs. Basically, the APIs do most of the heavy lifting for you. Everything is built into the toolkit, and you really have to do very, very little in terms of coding and adjusting these APIs to do what you want. And again, if you then want to port it to a different operating system or anything like that, it really is quite simple. Convenience is another one that we have on here. Basically, just about everything you're going to want to do with WinDriver can be done through a very easy to use GUI application. If it's easy enough for me to do it, as I'm going to show you in just a few minutes, then any one of you can do it, and probably significantly better. But hey, I'm assuming most of you guys are engineers and developers and the like, and I'm just a sales monkey. So if I can do it, you can do it. Another one of the advantages to being able to use WinDriver in this way is basically you get to do all of your development in the user space, but you still get to harness the power of the kernel mode without actually, or with much reduced risk of setting anything on fire. There have been incidents. I mentioned the cross compatibility, and in just a few moments, I'm going to talk about sort of the specialized FPGA support or enhanced support for certain systems and platforms. Uriah, if you could skip to the next slide for me. Thank you. So here you see a few snippets of the various levels and layers that WinDriver can work at or be operated with. Over on the left, or my left, you can see a snippet from the WinDriver wizard GUI application. This is where you're going to be doing most of the work and verification before you actually go ahead and generate code and actually start customizing your project. And this is a major portion of what I'm going to show you as part of my demo in just a few moments. Over to the right of that, at the top right, you can see a snippet of an actual user application that is generated by the wizard. And I'm going to show you that as well in just a moment live. And right beneath that, you have a little snippet of the WinDriver code itself. Today, we are not going to be diving into the code. That is a subject that we will probably cover again in the future, but we've covered it in the past in several of our other videos that you can see on the website, whether it's short form videos or longer form videos, including more webinars like this one. So I recommend that if you're interested in that aspect specifically, check it out on the website. Uriah, if you could skip to the next slide. This is great. It's like having a secretary and just slide. It's fantastic. So Uriah talked about some of the DMA IPs. So when we talk about samples and DMA samples specifically, this is more or less what we're referring to. So the DMA samples are basically ready-made example code that when you generate your project, you can work them directly into the generated project. Now I'm going to cover what that looks like again in my demo in just a moment, but it's important to understand what this offers. Basically, assuming that you use the IP as intended, or in its vanilla version, or just as it is direct from the manufacturer, our samples are ready-made and tailor-made to operate along with those IPs. Now, what you get as part of these samples is you get a performance test, which basically lets you make sure that the performance is up to par as you'd expect, so you don't just have to take our word for it. You can test it on your own, on your project. Customized DMA IP data, again, the offset, the descriptors, and all the other parameters will all be set in the code that is generated by WinDriver to match the IPs direct from the various vendors. And you also get additional things like the interrupt handlers, the DMA mechanism, kernel plugins, as well as many, many other functions and features. Again, most of these are covered in separate videos, some of which are dedicated to each one individually. So we're not going to dive into them too deeply here, but I do recommend that you check out those videos if you are interested in any one of these in particular. And again, you see that little line at the bottom just reminding us again of the cross-platform compatibility. So again, all of these things will be cross-platform between the different operating systems. Slide, please. So here you see a pretty comprehensive, if not complete, list of some of our DMA samples. You'll notice that for Xilinx, for example, we support the tried and true XDMA. For Altera, it's the Avalon. Lattice is somewhat new to the game for us, but we have sort of a special place in our heart for Lattice, as well as PLX. So the tried and true, the longtime players, the things that everyone's familiar with in the space. But we also make it a point to keep our samples at the cutting edge, along with things like the QDMA from Xilinx, the MCDMA from Altera, and again, like I mentioned, Lattice, the Avant from Lattice, which is really something that came out just a few months prior. And PLX, as I mentioned before, while tried and true, we do our best to continue to support as many as possible. Slide.
I just want to, in this occasion, just mention that we see here that Mustafa Nufal, if I pronouncing your name right, mentioned that he's using PolarFire in Avionics project, which is actually a microchip FPGA. So Mustafa, or if you like to, I don't know if it's interesting for you, but if you feel that you'd like us to support like more microchip stuff and tell us more about IPs that you've been using, that feel free to write us in the email that will appear in the end of the presentation, and we'd love to hear more about that. Because again, we are always looking to expand. This is just a list of what we have, but it's not the list of what we. It's not a comprehensive list, and it's not a final
Exactly.
list. Yeah. Carry on,
Yes.
Sean.
If anyone has any inputs, if you have, again, questions, recommendations, or things like that that you'd like to hear more of, are interested in, or even recommendations for us, really, at the end of this presentation, there will be an email. Please share your thoughts with us. So as far as supported devices or devices with sort of enhanced support, you can see here again some of the major players from this space, like Xilinx, Altera, Lattice, whether it's the Versal AI core from Xilinx, the Agilex family 5, 7, and 9 from Altera, the Avant from Lattice. But it's also important to note and not get caught up in these sort of bigger names. WinDriver, as I mentioned before, is silicon agnostic. Whether you're building the card from scratch yourself, whether you're using a player that I'm not mentioning here, for example, Microchip or Microsemi or anyone you want, you can use WinDriver with any of these hardware vendors. It just doesn't matter. Slide, please. Uriah, back to you.
Yeah, so I'm gonna interrupt Shlomi again just for one slide. So Shlomi is going to show you a demo of WinDriver on Windows with a PCIe device.
I
And
thought you were doing it.
no, 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 it's you. This time it's you.
Oops.
So yeah, you get prepared while I'm doing this slide. So let's talk a little bit about the device and the design before while Shlomi is getting prepared. Um, the reason that I want to discuss this a little bit is just to show you that this design, what's going to be interesting is that we're going to actually run this design on three different hardware platforms, totally different. The first one is going to be, again, Shlomi's demo with the PCIe and host and on Windows. And the next ones are going to be in a couple of minutes. So I leave you waiting for them. But let's talk a little bit about this device. So what is this device? It's a device called EDU or EDU by Kimu. Kimu is short for Quick Emulator, which is an open source project for virtualization. And one of the virtual devices that comes along with Kimu is EDU, and it's a device that exemplifies usage of PCI, uh, I/O, and interrupts, and DMA, and lots of stuff. So we're in order to keep our demo short, we are going only to exemplify two things from this device. The first one is writing to the bar to offset 4. So if we are writing something to offset 4, then we get a simple value inversion. So the bits are flipped. For example, if we write 0, then we get all ones. Or in hexadecimal, that's all Fs. If we're going to write 5555, we're going to get AAAA, because 5 and A, if you go to your nearest binary calculator, you'll see that 5 and A are inversions of one another in binary. So that's something we're going to do it a couple of times during this presentation, just to show you that the design works exactly the same whenever or wherever we put it. And that's a nice thing to see. And the second thing we're going to show is we're going to use offset 60, where if we write to offset 60, then we raise an interrupt in this device. So this will be used to show you how WinDriver could actually run a callback when an interrupt is intercepted. And this callback usually is going to print something like got interrupt or interrupt received or something like that. But you could put any code inside that callback. You can do anything you want. You can fly a rocket to the moon even when that
That's my
interrupt,
life.
yeah, when that interrupt is intercepted. So that's one of WinDriver's features, is to allow the user to write their own interrupt callback handler. So I'm giving the floor back to you, Shlomi, but this was just an intro on the device we're going to be working with. Go ahead.
Okay, I need you to let me share my screen instead.
Could you share now?
Yep, thank you. Okay, can you see my screen?
Yes.
Excellent. So obviously I was kidding. I knew that I would be doing this. We're joking. So once you install WinDriver, which is a fairly simple task, and we're always there to assist in case you need us, you're most likely going to go directly to the driver wizard, which is what you see here on my screen. From there, generally, you would probably start a new host project, which looks like this. So what you see here is a list of all the devices that are currently connected to my development machine. In this case, it's just a laptop that we use for demos, which is somewhere in the office. And you can see a little bit of information about each device that I pull up. Today, as we said, we're using the EDU device, which is this one here. And I'd like to draw your attention to this little box over here on the right. You'll notice here that after there's some information about the device, we see a little box saying, or a little parentheses saying requiring driver WinDriver 1650. So what this is referring to is the device INF, which if you've ever done any type of driver development for Windows, you know that the INF can be very tricky. It can be very difficult to do if you don't know what you're doing. And it can be a major hurdle to actually getting started in the actual development of the driver. But with WinDriver, another advantage, particularly for Windows, is that creating an INF is a very, very simple task. No more than clicking the Generate INF button, making sure all this information is correct, and in fact, even installing it is just ticking a box and clicking Next. Today, I'm not going to be doing that. For today's demo, just to save time, we've done all this in advance, so I'm just going to click to the next stage. But it is literally that simple to do. There can be a little bit of processing time depending on how you're doing it, but it shouldn't take up any more than a few minutes as far as generation. So from there, what you would generally do is click Next. And when you click Next, you're going to be taken to a new project. Now, again, we aren't going to be opening a new project today. I'm going to be opening an existing project, which we've done before, again, mainly for simplicity and time saving. When you open the project or when you create the project from scratch, you're going to be greeted with a configuration space. Within the configuration space, you're going to see some more information about the cards, about the card that you're currently using. You'll see all the details it has to offer, the descriptions, the data, the access, the registers, everything. Now, not only that, as you can see here in the left panel, you can see the bars that the device has, as well as the fact that it supports interrupts. Now, an interesting thing about the wizard is it's not just a place to display this stuff. You can actually start working with it, verifying it, and checking it. And I'm going to show you exactly what that looks like just now. I'm going to start listening to interrupts. I'm going to go into my bar. I'm going to read and write. So as we said, we're starting off with offset 4. And we're going to do 1, 2, 3, 4, 5, 6, 7, 8. So 5, 5, 5, 5, 5. And we're going to write to offset 4. As I write to offset 4, you can see that it's there now. The next thing I'm going to do is read. And as we said, our 5, 5, 5, 5, 5, 5, 5, 5, 5 has been inverted into ah, or a bunch of A's as we expected. But wait, there's more. We were talking about interrupts. So if I go ahead now and I write to offset 60, as I go ahead and write to offset 60, we're going to see that the wizard raised that it got an interrupt. You can see it down here in the information panel. So I want to draw your attention to one major fact here. I've created an INF. I've begun to verify, manipulate, and perform operations with the card. I have not configured anything. I have not written a single line of code. I've not generated any code. I've basically done very little besides click through a few menus in order to actually start operating a PCI device on this machine. But this is only step one. Once you have all this ready, once everything is working as you're expecting and intending, the next thing would be to generate code. As you click on generate code, you're going to be taken to this code generation options. Now, there are several options here, and they vary from choosing your development, your code generation language, as well as your IDE, to choosing the sample. So this goes back to the ready-made example code that we provide, where you can see several of the options are here. So this is going to actually be generated directly into your project. So as I mentioned before, today we aren't going to be doing any generation because there's some lag time between when you actually start this and when it spits it out on the other end. But I'm going to show you exactly what you would get on the other end. So as I go into my examples, you can see here some of the files that were generated for this project. Today, we're only going to be talking about one of them, but again, it's just for demonstration. And you can see that it was done in Python. So as I go ahead and open this, you can see here that we have a user application ready to go. Now, the cool thing about this user application is I'm actually going to be able to perform the exact same operations that I did a few moments ago within the wizard, but now in a generated user application. So there's no instance of the wizard working in the background. What you see here off to the side, this is our WinDriver debug monitor. This is sort of our main point of communication with you for support in case, when and if you need it while using WinDriver. If you have any issues or any questions while using WinDriver, we are going to be asking you for this. So generally what we found is most people, if they have an issue, they'll read through this and they'll find it themselves. But just in case you don't, then we're going to need that information. But now I'm just going to go ahead and I'm going to go through this. So the first thing is I am going to raise my interrupts, or I'm going to enable my interrupts rather, and I'm going to go back out into my main menu. From there, I am going to read and write just as I did before. So then we have 5, we're going to write to offset 4, and we need to do 1, 2, 3, 4, 5, 6, 7, 8. This is mainly to make sure that I don't screw it up, that we're using the whole line. But you can see here that we wrote to offset 4. And from here, what we're going to do now is we're going to read from that same offset. Now, when we read from that same offset, we should see, as you can see here, that we have the inversion just as we did in the wizard. Now we're going to go back out. I didn't actually need to do that. I could have gone direct. That's all right. So now we're going to go back to write, and we are now going to write to offset 60 in order to raise that interrupt. So as I write to offset 60, just going to put a 1 there. You can see here that we got an interrupt, just like we did in the wizard, but now it's at a functional user application. Now again, it's very important to note, and I want to draw your attention to it again. I know I'm harping on about it, but I just showed you how I performed these operations in the wizard and how I've now done them in a generated user application without writing a single line of code, without configuring anything, without adjusting anything, changing anything. In fact, I couldn't do any of those things even if you asked me to. I'm that inept. But I was able to perform operations on a PCI card right here in front of you. None of this is recorded, obviously. I asked them to record it. They said no. But I was able to do this. I didn't set anything on fire. Nothing exploded. There were no errors. So if I can do this, anyone can do this. And it can be as complicated as you want from that point on. From here, I'm going to hand the stage back over to Uriah, and he's going to show you how it's done by the professionals.
Okay, so just stop your sharing, please, and we're
No, it's
almost
mine.
back. We're back to the presentation. So, okay, so up until now we were talking about PCI plus host configuration, and that's the classic way to use WinDriver for over 25 years. We've been around with Django and WinDriver. But now, after all this time, we actually decided that we want to get into new areas. And one of these areas is the SoC or SoC configuration. So what happens here? So basically, this is called an AMD Kriya, the specific SoC that we see on the presentation here. And this is behind this fan, we actually have another FPGA chip, just like this one, but it's hidden by the fan. So I think everyone can notice that this board or this evaluation kit has a PCI teeth that allow it to be connected to a computer and act as a PCI device, but this one doesn't. So many FPGA users and designers and customers use FPGA in the SoC configuration. And what's a SoC? A system on a chip. It
Something you put on your
allows
feet.
exactly. It's a system on a chip. So this also has a CPU and it allows it to run operating systems like RTOS or Linux. Um, so when do you use a SoC actually? If your feet are cold, of course, Romy. I know you're smiling. But if you don't need host PC connectivity, then that's a good time to use a SoC. If you want an independent computer for field applications, for example, I don't know, you don't need like a huge computer to put this huge evaluation kit on. This is actually a pretty small machine. And you can take the good thing, and that's not something new, that you can take your hardware design and apply it to SoC configuration or PCIe configuration and just move it around. All you need to do is just uh, change the design a little bit to fit to a SoC configuration or a PCIe configuration. So the new feature is that from the next version that's going to come out in a couple of months, WinDriver is going to support SoC platform devices running Linux. What is platform device? That's the Linux name for a device that is not a PCIe device, but it's a logic device coming from the FPGA. So what's the workflow then? Like we just show you the workflow for PCIe, the classic workflow of WinDriver. So now what needs to be done? So first of all, you fit your design for SoC. So you take your design, you fit for SoC, remove the PCI parts, put in the SoC parts. Then you program your SoC's FPGA with that design that you made. And then voila, you use the same WinDriver based driver you would use on PCI, same offsets, same APIs. No need to do anything special, actually. Just recompile the code with a minor tweak. I'm not going to show here the recompilation just to keep the presentation short, but it's practically just changing some define in your compilation, and that's practically that.
There will
So
probably be a video dedicated to that in the future.
yeah, of course. And our slogan is we either do it for you or assist you and support you in doing it on your own. So even these two parts, if they're hard for you or complicated, we can help you in doing these two. So let's look at Edu again. So Shlomi worked with Edu to show you the PCI version of WinDriver. And now let's look at the platform device version. So you see, that's the same logic that we had from before, but now instead of being connected to a PCI IP, it's connected to this Zinc UltraScale Plus MP-SoC IP with all these other blocks lying around here. I'm not going to get too deep into this, but this is the exact same logic that our in-house FPGA engineer wrote in accordance with what the virtual device that came from Kimu did. So we have actually a physical version of that virtual device. So let's see a demo. I'm going to quickly share my terminal screen. So I just SSH'd into an actual Kriya device that we have here, like an SoC. And it's running this Linux 6.8 Xilinx version, running ARM64. And I don't need to do much, actually, because I can just use I have WinDriver already installed on this machine, so I can just CD into the directory of this new diag sample application that we have in sample C. It's called platform diag. Usually, if you know WinDriver from before, you know that we have PCI diag. So platform diag is practically almost the same code, but again, it's compiled a little bit differently. And this is the ARM64 version of WinDriver. The exact same version, no big changes. And if we CD into that and we just run the platform diag, sudo, of course, then we can just instead of scanning for the device as we would do in PCI, now we could just write the name of the device. And now we've opened it. And I'm quickly going to show again the same things that Shlomi showed you. First of all, I'm going to enable interrupts. Then I'm going to write to offset 4, invert some bits. I'm going to invert A's into 5s.
You're going to
Voila.
invert what into 5s?
A's, A's into 5. Yeah, so that was inverted. And now let's raise an interrupt quickly. So I'm writing something and let's see. Yep, we got an interrupt. Okay, so the exact same logic running on an SoC with WinDriver. And again, I didn't touch the code. Unlike Shlomi, I'm the head of the R&D. I do know a little bit of coding, but still, I didn't touch the code. It just worked out of the box, really. I mean, you just install WinDriver, run this code that we provide with WinDriver, and that's it. Like no coding to do, and things just work out of the box. One last thing that I want to show you in this demo before I leave it is that another important thing to do in order to set your design to work with the Kriya or with any kind of SoC is building a device tree, and that's important for in order for WinDriver to be able to recognize your platform device. So there is a tool that comes with Vivado and also a parallel tool that comes with Quartus that allows you to create a device tree file. It's called DTBO file. And once this is installed on your SoC, then you're good to go. And WinDriver will be able to work with this device and be a driver for it. And the nice thing, again, I'm repeating this, is that you can just take your own driver code from the PCI version and just put it here. And you can take your own driver code from the SoC version and just put it in PCI. Just interchange them as much as you like. Uh, and the APIs are the same, the offsets are the same, everything just works exactly the same. Um, okay, so let us get to back to the presentation, and we have a quick poll. Voila. Another quick poll for you. Yeah, so we're giving you again 1 minute to answer it.
Again, we apologize for the lack of music or entertainment while filling out a
Yeah, actually, next
a
next
single second poll.
I think next webinar we're gonna do
Sing
it.
and
Actually,
dance.
actually, it's interesting that I see some people marked other, and that's very interesting because I'm really curious what is other actually means. So you can write us later on in the end of the webinar. You can write us what does other mean in your case.
Please,
Okay,
please do.
yeah, feel free to do that. You have 15 more seconds, so come on, you can do it.
What will we do with all this time?
Yeah. All right. So we see that we have 83% using SoC only, then 58% using PCI plus host, 17% are using cloud, and 17% are using other. So that's very interesting, actually. So I hope that this new feature with the SoC would be interesting for you. The way
Mm.
to just interchange your driver between PCI host and SoC only configurations with practically the same code exactly. That's a very nice feature. So we have a couple of more minutes, and I want to get back to the presentation and show you the last section, which is FPGA on cloud, which is also a new feature coming from WinDriver. And let's talk a little bit about what is FPGA on cloud. So I mean, first of all, let's say that you don't have a physical FPGA device available, but you want to program or to create a hardware design. So you can use a cloud instance in Amazon or in Azure by Microsoft or in AWS by Amazon. And they can give you an instance with an FPGA far away. If you would like to scale up or down quickly and easily, let's say that you have an FPGA device available for you, but you know that these devices cost from hundreds of dollars to tens of thousands of dollars. And let's say for this week you want 10 devices, but you just need them for 1 week and then you don't need them anymore. So using a cloud FPGA, maybe you can scale up very quickly and then scale down when you just don't need a device instead of just throwing them away. It's Shlomi.
If you're throwing them away, let me know where. I will come get them.
Yeah, yeah. I think Shlomi could make a nice buck out of the FPGA devices you're going to throw away. But these are very expensive. Usually the good ones are very expensive. Uh, if you would like to share work between remote teams, for example, if you have teams working all over the globe, that's also a good way to share the FPGAs. If you would like to deploy FPGA-based products without actually selling the hardware, we have a lot of customers in WinDriver that actually sell FPGA hardware pre-programmed with their designs. Maybe it could be a nice, interesting use case for you that instead of actually sending the hardware to the customer, maybe you could just sell them in cloud instance with that logic programmed on that, and then you don't need to actually ship them the FPGA. So it really depends on the usage and the use case, but these are interesting use cases that could be relevant for FPGA on the cloud. And where does WinDriver come in? So we are now introducing a new thing called WinDriver Cloud. And WinDriver Cloud allows you to do a couple of interesting things that make life much, much easier for FPGA engineers, for people who need drivers, and even if you're a very, very like an expert FPGA engineer, I can tell you from our FPGA engineer that using FPGA on the cloud could be a major headache. It's not that easy. And is it not that easy? Because you need to fit your design to your cloud provider. And the problem is that if you have a design, specifically in this webinar, we're talking about AMD because currently only AMD actually provide cloud instances of their FPGAs, but we know that Altera is also working on that as we speak, and it's going to become available soon. So if you want to fit your design to work with Azure, you need to do a certain process, which is not an easy process, and then fit it. But if you want to fit it for AWS, you have to do a whole different kind of process. It's not the same process. And that's a huge headache if you want to switch between clouds, for example. If you want to just create the instances, that's also a lot of headache, just configuring them, making sure they're right for you. And that's a lot of things to do. So in this workflow, actually, we can help you with this first bullet, but the second bullet is something that we actually do for you. We actually bring up the machines for you. We actually program them with your FPGA design for you. We're just going to show it in the demo in a minute. And then after we did that, again, you can use the exact same WinDriver based driver you would use on PCIe. No recompilation, same offsets, same APIs. Everything works exactly the same as on your home computer or your office computer. And that's just amazing. So again, the slogan is we either do it for you or assist you and support you in doing it on your own. I'm talking about this part. Okay, so let's look at a different version of the same eDO device. Okay, so that's the actual logic, but now instead of being connected to the Zynq, it's connected to this Amazon Web Services block. And that's something that they require in order for you to program FPGAs on their cloud. So we already did that in this version of eDO. And now I'm going to show you the demo. Okay, so I'm gonna share a different screen now. Here it is. So this is the WinDriver Cloud GUI, and it's a brand new GUI that we made. And from here, you can just choose how much instances do you want. You want 5, 6, 10, whatever. For now, we're just going to choose one to keep it simple and to keep it short. And you need to create an AFI. What's an AFI or AFI? It's the Amazon FPGA image. Like you need to take your design. I'm not going to really do it now because it takes Amazon 15 minutes to do it. And it's a very tedious process if you do it without our tool. I can tell you that. But you just need to take your tar, that this is your design. This is the same design that I showed in the previous slide. And you need to create the AFI from it. And once you created that AFI from it, then you can actually program the FPGA cloud instance. So we've already did that to keep this demo short. So these are two AFIs that we already have. So we're going to take eDO AFI fixed here, and we're going to start an instance and then program it with that design. So as you see, it's doing everything for us. It's starting the instance, launching it, and after it's going to be launched, it's going to be programmed. So let's give it a couple of seconds to do that. And now it's ready. You see, I already have this SSH command that I can use in order to log in to that instance. And now it's programming the FPGA on the instance. While it's doing that, I'll talk about the other tab that we have here. The AFI management is the tab that allows you to reprogram the device or create AFIs without bringing up new instances like you do on this tab. And then the deployment tab allows you, and that's something I'm going to do. Yeah. Let's try to do it again. Let's program all instances and see. Um, Sometimes it doesn't work on the first try, so I'm just going to give it another shot. Uh,
That's how new it is.
yeah, exactly. It's still in the beta phase, by the way, so it's not even out there, but we're giving you a sneak peek of the new feature
Yeah,
that's going to come out in the next version.
a peek behind the
Uh,
curtain.
yeah, so in the deployment tab, we can take a WinDriver package. So in the classic WinDriver, you can just take your CMake package and just pack it into this SH self-extracting file installer. Now the FPGA programming is complete, by the way, so I was right. And you can just redistribute this to any of your customers. That's a regular thing that you would have done with WinDriver anyway. But now in the cloud, we also give you this tab that you can just deploy it quickly and install it on your instance. So now I'm just going to deploy this on my instance, this example that we have made from before. And now it's not just going to copy that file into the instance, it's going to also install that driver. And now we're going to have like your rename. These instances already spin up with WinDriver installed on them, but now we're going to also have the renamed WinDriver driver installed on these instances too. We're going to have only one instance for this example. Rename driver installed, and I'm going to run it in just a moment. So while it's installing, I'm going to copy I'm going to copy the SSH IP address, which is 35.175.228.92. Okay. Yes. And now I'm logging into this machine.
Ready.
Yep. And with the WinDriver logo. And you can use the regular WinDriver PCI diag here if you want. But since we already installed the rename driver, let's use this one and run it. And I'm going to show you the exact same things running on the cloud instance. Yep. So I'm going to open Edu again. That's our device, and we cannot find it. Okay. I'm going to give it
Uh,
another.
you need the
Mhm.
device name?
Um, no, I think I need to reprogram it, so I'll give it another shot. And if that doesn't work, then it doesn't work. But I think I just programmed the wrong device, so that's a mistake. So I'm just going to do it again. And it's pretty fast, so I'm not really worried. Um, and there, it's complete. And let's try again. Okay, let's try again.
You didn't know you were getting a live debugging session as well.
Yep. Yep. And here's the device. So you see, that's what happens when you program the wrong program to your FPGA, by the way. I guess if people here are using FPGAs, you know what I'm talking about. So let's do everything again. Okay. Enable interrupts so we can listen to the interrupt coming when we raise it. And then I'm going to invert some bits, right to offset 4, A, and then read it. And we got 5s, just like we would have got them anywhere else. And let's raise an interrupt in offset 60. And we got an interrupt in offset 60. So again, the exact same logic running from a remote FPGA instance on the cloud. And the nice thing is I finished my work now and I want to scale down, right? So we talked about scaling up. Now I want to scale down, terminating all the instances, and that's it. Everything's removed. Okay, so we have just one last thing, one last poll to ask you.
This is the last one, or the last official one. I have a
Yeah,
question at the end for an unofficial poll.
yeah. And then we're through. So thank you for staying a little bit more with us, but we're almost done. Um, and thank you for your patience and participation. So this is the last poll. Would you use WinDriver Cloud? Do you have a use case for this? Maybe it's relevant for you, maybe it's not, but we would love to hear. And we give you 2 minutes to answer this because this is an open question. So
Yep. So go ahead and take 2 minutes to give us your insights into would you use WinDriver Cloud? How would you use WinDriver Cloud? Any opinions that you may have on it, you can put right here. And for my unofficial poll, I'm going to tell you what it is. Who wore it better? Which one of us ran a more impressive, more fun demo? This is pretty much just an ego boost for me, but or at least a shot at one. But yeah, obviously, let us know what you think of WinDriver Cloud. That is important to us to know that there's interest and that some people might have a real use case for this.
yeah, and I got to say that even though I'm the head of R&D for the product, so Shlomi is a senior account manager and his specialty is sales, so I'm pretty sure his demo was better.
Yeah, mine didn't have any errors. Just saying.
Yeah,
Just
flying colors. Okay, you have 30 more seconds to answer this.
so I have to fill 30 more seconds while they're doing this. Uh,
Anyway, if you feel that you're not finishing it on time, it's okay. You can answer it later on and write us in
sure.
private if you want. But we're seeing actually a nice response rate, which is nice.
So thank you all. We do appreciate that.
All right. Okay. So I think can I leave it open and people are still seeing the
Yeah,
presentation?
sure. While we wrap things up, I
Okay.
don't see a reason why not.
Yeah. Okay. So I'm gonna show the last slide. So let's summarize everything we did today. So we use the same hardware design logic on three different configurations: PCI plus host, SoC, and cloud. And we showed you that I don't think it's something that if most of you are FPGA users or engineers, I don't think that surprised you too much. But I think the driver part, that's the new thing is that WinDriver could work with all these different hardware platforms and do the exact same thing, exact same code. You don't need to write the code over and over and over again when you switch from platform to platform. When you switch from operating systems, right? We saw Windows, we saw Linux, we also have RTOS, Zephyr, and macOS, and different platforms of Linux ARM as well. And so you have all these different ways to use WinDriver, write once, use many times. And that's, I think, a very nice thing that we offer. So thank you very much for joining us today. And I'm giving the floor back to Shlomi.
Yep, just some final words before we check if there are any questions or anything anyone would like answered. So first of all, thank you, Uriah. That was great. I'm glad we were able to cover so much. I also just want to mention one more thing about that final slide. When Uriah was mentioning that, if you want to support one or the other, they're easy to move between. They're also easy to maintain simultaneously, particularly because it's pretty much the same code. So it's whether you want to work in different operating systems, on different configurations, if you want to maintain multiples of any of these combinations at the same time, then WinDriver is just a great, great tool in order to do that, particularly because we also include basic technical support. So any type of thing like that would generally be under that. So you can skip that back to the final slide. So I just wanted to thank everyone again for joining us today. I know it's not an obvious ask to have people take an hour and change out of your busy times and busy days just to sit here with us. I hope you enjoyed. I hope you had some fun. I hope this wasn't just a dry technical sort of webinar for everyone. As I mentioned before, if you'd like to schedule a meeting with me and either discuss WinDriver, talk a little more about how you could incorporate it into your workflow, if you want to hear more about it, if you just want to say hi, or again, like I said, if you have any movie recommendations, the book recommendations, video game recommendations, I'm happy to have a chat. Anything you'd like to talk about. So my link in bio, right? It's in the chat. So if anyone would like to schedule that, you're more than welcome to. And you also have an email here, sales@jungo.com. That's SALES at JUNGO.com. So if there's anything you'd care to email us, if you want to ask us questions, if you want to share your thoughts, if you have any recommendations or anything else that you would like to go to the team at large, then we're more than happy to get that input over at sales@jungo. And now let's see if there are any questions that you guys posted in the chat that we may be able to answer.
Nope, I don't see any questions.
All right, going
So,
once, going twice. Sold. All right. So for any questions that that you guys didn't share here. Oh, wait, we have a question.
oh,
Please,
okay, Mohammed, go ahead.
Muhammad, please.
Okay, and I see also Antonio has a couple of questions. Um, could you elaborate more on the question? Because you said PCI switch profiles. So if you could like phrase it as a question so we'll know better to address it. But even if we won't be able to address it now, then I'm pretty sure that you and Shlomi could take it offline. Yeah. Okay.
Sure.
So yeah, so do it offline, and I'm sure you and Shlomi, or if you need me to answer them, then of course I'll be glad to help Shlomi because we sit right next to each other in the office, and
Despite his best efforts to run away and sit in
exactly.
a different office.
Okay.
Muhammad, so you asked, so what kind of real project you can use WinDriver for? Pretty much any project that requires any type of USB PCI or PCIe driver, anything from non-destructive testing, medical equipment. If you have a use case that requires a PCIe connection or a PCIe bus, then generally WinDriver could be an applicable solution for you. It really depends on your project and what it is that you're trying to do. But yeah, if you have a specific use case that you want to know if WinDriver is a good fit for, please feel free to shoot me out an email, and I'd be happy to try and address that for you separately.
And
Antonio, as well, I'm happy to take this offline and we can discuss it a little bit later.
I just wanna correct Shlomi because he said PCIe or USB, but now it's no longer PCIe or
That's
USB,
true.
even if it's just an
That's
SoC
true. That's true.
project.
You see how ingrained the PCIe thing is with me. That's right. That's true. So any type of
So
FPGA, PCIe, SoC cloud application that you may have.
yeah. Okay. Okay. So I think Mohammed, I think that it'll be good to take this offline with Shlomi. Um, but in general, we have I think thousands of customers, right, Shlomi? Like many companies.
Easily thousands.
Yeah, many companies that big companies that you know, and you can check out our website, by the way, to see success stories of big companies that use WinDriver for various types of projects. And the main thing is that it's easy. I mean, we tried to show you in this webinar that it's really easy, and we have very wide documentation. We didn't even have time to get into that in the webinar, but wide documentation, wide support, lots of years of experience, and so forth. Yeah, so I think we could wrap it up for today.
Yep. Again, if anyone has specific questions, Mohammed, I feel like there may be something there that you're trying to ask me about a little more directly. So if you do have a particular use case in mind, please reach out and I'll see how I can help you. Antonio as well. I'm happy to take this offline and we can go a little more in depth. So thank you everyone very much. I hope you have a great rest of your day. And again, if anyone would like to schedule a meeting, the link is there in the chat, and you have the email right here in the slide. So everyone, have a great rest of your day. Uriah, thank you for taking the time out of your, I know, extremely busy schedule to do this. Thank you, everyone, and just have a great day.
Thank you very much. Thank you all for joining.